Hi, it's Professor Adam. Let's take a look at some worked examples of condensed and structural formulas, including some types of questions that you may see in your future tests, quizzes, or exams. So our first problem is, what are the empirical, condensed, structural, and skeletal formulas of butanoic acid if its molecular formula is C4H8O2? The first one that we will start with is our empirical formula, because that is just the simplest number ratio of all of the atoms which are in the molecule. So we're given C4H8O2, which would mean that the simplest number ratio then of our molecule would be C2H4O. So that's our empirical formula right there. So the next one is, we want to know what the structural formula is. So the best way to go about this is really just to create a Lewis structure for our molecule, butanoic acid, if we don't know anything else about it. So we have 4 carbons in our structure, so that will give us 4 valence electrons each, which would times 4 gives us 16 electrons. We also have 8 hydrogens, and so those 8 hydrogens, so 8 times 1, will give us 8 electrons. Then for our oxygens, we have 2 of those, so they have 6 valence electrons, and so that will contribute 12 electrons to our final structure. This gives us a total of valence electrons of 36. 36 valence electrons. Okay. Next thing is to create, of course, a backbone for our Lewis structure. So our carbons will form the backbone, as they're the least electronegative. So we'll put those out in a straight line first, and then we will attach our other atoms to that. So since I'm going to apply a little bit of my chemical knowledge and say that I know that a carboxylic acid has a structural motif somewhat like this, with 2 oxygens attached to 1 carbon. Then I'm going to put the other hydrogens throughout the molecule, like so. Okay, so now I'll count up the number of bonding pairs that I have. So I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13 bonding pairs. So 13 times 2 means that I have 26 electrons which are occupied as bonding pairs. So that leaves me with 10 electrons free. Then, as per Lewis rules, I put those on my most electronegative atoms. So those are my oxygens. So those get lone pairs here, and oxygen gets 3 lone pairs there. So next thing is to check that everything successfully completes its valence. So the hydrogens are all okay. The carbons are pretty much good. The oxygens are good. The only problem is this carbon here, which does not in fact have a full valence. It only has 6 electrons. So what happens next due to Lewis rules is that these electrons from this lone pair hop back in and are shared with the carbon to form a double bond there. So that gives us a double bond there. And so I know this from my chemical experience, that this is what butanoic acid's structural formula will look like. Then the next thing is to form a condensed formula. So the condensed formula for this would be CH3, CH2, CH2, CO2H, or I could also write it out as CH3, CH2, then in brackets 2, because that's the same structural motif, CO2H, or I could write this carboxylic acid part out as COOH, and then the rest remains the same. Those are all valid ways to write out the condensed formula for butanoic acid. And then the last one we're asked is the skeletal formula for butanoic acid. So we'll draw it out. So there's 1, 2, 3, 4 carbons. Then we have the double bond oxygen there, and then the OH here. And then that is our skeletal formula. Let's just count 1, 2, 3, 4 for our carbons, 2 oxygens and 1 hydrogen. And then the rest of our hydrogens are filled in there. And so we have our skeletal formula as well. And so we have, let's just check, we have our empirical formula, which is up here in the left. We have our condensed formulas, which are any of these. We have our structural formula, which is here, and we have our skeletal formula here. So this is what those formulas look like for butanoic acid. So the next question then is number 2, and we're asked, what are the empirical, molecular, condensed, and skeletal formulas of benzene? The structural formula is given below. So the structural formula is here, so that's our Lewis structure already, so we don't need to worry about that. So the next thing is, the easiest I guess is just to go for the molecular formula, which will just be the total of all of the atoms which are present. So we have 6 carbons, 1, 2, 3, 4, 5, 6, so 6 carbons. We also have 6 hydrogens, and so our molecular formula is going to be C6H6. So that's our molecular formula. Our empirical formula then is going to be CH, because CH is the simplest ratio of this. Then the next thing is going to be our skeletal formula. So that's pretty easy to do as well, because we're already given the Lewis structure. So in the skeletal formulas, we typically will omit the hydrogens. And so we'll just draw out our hexagon, which shows our benzene ring structure. Then fill in some of our double bonds, and we have the skeletal structure there. So there's the skeletal structure. Okay, and then the last thing, so we've got our empirical, we've done our molecular, we've done, and we've done our skeletal formulas. Now we need to do this condensed formula. Now that's a little bit trickier. We haven't come across this yet, but thankfully the IUPAC committee has given us a method in which we can write out our condensed formula. So in the case of our benzene ring, we have 6 CH groups. So 1, 2, 3, 4, 5, 6. So this would be all containing all of the carbons and hydrogens there, but there's no real indication here of the cyclic nature of our benzene. And so the way that we've been told to do this is to draw a little line either above or below, which connects these two atoms, the two carbons. And so that will give us our condensed formula. Another way potentially of writing this out would be CH and then in brackets CH4 and then another CH there and then putting it here. Now this line connecting the carbons can be above or below. It doesn't have any particular rule with regards to that, just so long as the two atoms which are connected are indicated. And so this would be our condensed formula. Okay, and so then the last one that we're going to deal with today is a little bit tricky. So we're now dealing with an uncommon structure. What are the empirical, molecular, structural, and skeletal formulas of N-methylimidazole if its condensed formula is CH3NCHNHCHCH? So it's also, we see that there is a connection between the nitrogen and the carbon, and so it is cyclical in nature. So the first thing that we want to do is use this information to find our structural formula. So we know that there is a nitrogen which has a methyl group attached to it. So there's our nitrogen, and we'll draw our CHH out like so. Then we know that there is then a CH group attached to that. So here we'll put our carbon, and then we'll put that has a hydrogen, and then we know that the next one has a nitrogen, and then we know that there is a carbon attached to that which has a hydrogen attached to it, and then that carbon then has another hydrogen attached to it, and then that carbon is in fact attached to the nitrogen that is back at the start. Then we can look in and we can see that some of these nitrogens don't have sufficient bonds, and so we'll place a double bond there, and we'll place another double bond here. Just tidy this up a little bit. Put our like so. Okay, so that will be our structural formula. Then from this, and also from the condensed formula, we can create our molecular structure, which will be, there are 4 carbons here, so it's going to be C4. There are then 6 hydrogens, and there are 2 nitrogens, so that's going to be our molecular formula. And then we have our empirical formula, which of course is, as always, the simplest number ratio of these two. So we have C2, we have H3, we have N, and that is going to be our empirical formula. Okay, so now we have our structural, we have our molecular, we have our empirical. We just need our skeletal formula, so we base that on our structural formula, and we'll have something like this. And there we go. We have our skeletal formula. You could also write it out like this. Either one of those is fine. So that's our skeletal. And then we have our structural over here. And we have done our empirical, our molecular, our structural, and our skeletal structures, and we are very happy. And so that's a kind of a few examples of the types of questions that you might see. You might not be asked for all of the different types of formulas, but at least now you're kind of aware of the different formulas that can be asked and which ones are potentially going to crop up in exams in the future. So thank you for watching. Bye-bye.